Welcome to the tutorial on digital electronics. This is quite a long tutorial and I'll be breaking it up into different activities. We're going to start by looking at two input logic gates and just making sure we understand exactly what each logic gate does. To do that, we're going to be needing a switch input circuit and we're going to be needing an output circuit. We're going to be needing two of these switch input circuits and just one for our logic output. Very quickly, having a quick look, when we press this switch, the input to our 555 inverting buffer which we're using will go low, and when our input goes low, our output will go high. So we know that when we press our switch, the output will go high. Likewise, we know that when the input to this logic circuit goes low, the output will go high and therefore the LED will be off. So when the input is low, the LED will be off. When the input is high, the LED will be on. So we know that with digital electronics we only have two states. I'm not going to go into too much detail on it. And those states are either high or low, on and off, 1 or 0, 5 volts, 0 volts, however you want to explain it. I will probably be using the terms high and low. So I've built two input circuits here. I'm going to call them A and B. Now, I've labelled them up for you because A needs to be on the right and B needs to be on the left. This is for our binary maths, which we'll come on to later. So let's check our circuits work first of all. Now to do that, we can do that a number of ways. We could use a voltmeter to make sure the outputs go high or low, but actually what we're going to do, we're going to be using this little tool here, which is very useful. This is called a logic probe, and this indicates whether something is either high or low. So if we go to our power supply, and I've connected up my logic probe to my power supply, and that needs to be connected to the one that you're using to supply the voltage for your circuit. You can't do it separately. When I connect it to 0 volts, it will go low and the green LED comes on. And when I connect it to high, the red LED comes on. It's a good way of checking whether you've got power going to a circuit. So if I connect it to my power, high, connect it to my 0 volts, low, and I can check anywhere in the circuit to see whether I've got power going to wherever I need to. So let's check first of all. This is the output of my switch A circuit, which is pin 3 of course. So when I press the switch, it should go high, and it does. So that's the first thing to check. Next, I'm going to check switch B. Currently low because the switch not pressed. Press it, goes high. Good. So what I can now do, you will see that the LED here is on, but I don't actually have a signal going to my output circuit. So I'm going to connect switch A to my output circuit. You saw the LED went off because my switch is unpressed. So when I press the switch, it sends a high, therefore the LED should come on. I'm going to disconnect that and connect up switch B and check that B and the output circuit work. Good. So I now know both my input circuits work and my output circuit works. Now the 2-input AND gate is a 4081 CMOS 4000 series chip 4081. There are 4 different AND gates in here. You can use any of them. The important thing to recognise is the power pins, which is positive is pin 14 and negative or 0 volts is pin 7. We're going to be using two inputs, A and B, hence the switch names, and therefore we will have an output. So I'm just going to be using pin 1 and pin 2 as my inputs and pin 3 as my output. So what should I be expecting to see here? I should be expecting to see that when both switches are unpressed, the output is low. When A is pressed, the output is low. When B is pressed, the output is low, and when both of them are pressed, the output should be high. This is an AND gate. In other words, when A and B are pressed, the output will be high. Apart from that, none of the others will give that output. So let me put my first chip into the circuit. This is a 4081. Making sure it's located well down into the breadboard. I'm going to connect A up to pin 1. I'm going to connect B up to pin 2. And my output is now going to go to pin 3. So when I press A, the LED remains off. When I press B, the LED remains off. And when I press both of them, the LED comes on. So that holds true with my truth table here. A and B, the output goes high. A little bit of extra information here is telling you that the dot, i.e. A and B, the dot represents an AND operation. This is called Boolean algebra and actually comes up in A level, but it's worth mentioning because in quite a few of the textbooks you might well see that. So let's move on to the second practical. And we're going to be looking at an OR gate. So once again, it's a quad 2 input OR gate. The number on it is a 4071. Quad means there are 4 of them inside one DIL package, dual inline package. And fortunately for us, the pinouts are the same again, so we can use pin 1 and pin 2 as the inputs and pin 3 as our output. So looking at our truth table, 0 or 0 gives a 0. When we press A, it should give a 1. When we press B, it should give a 1. And when we press both of them, it should give a 1. In other words, when A or B is pressed, it will give a 1. But it also gives a 1 when A and B are pressed. Okay, let's have a look at that one. So I'm going to remove my 4081. Put my 4071 in. I press A, the LED comes on. I press B, my LED comes on, and I press A and B, and my LED comes on. So A or B and both. Good. So that was our OR gate. Going to have a little look now at something called a NOT gate. There's a reason why this is coming in this tutorial right at this point. You'll notice that it only has one input and one output, as always. And what it's telling us is that the input A, the output will be opposite. In other words, it's not A. So when the input is a 0, the output will be a 1. When the input is a 1, the output will be a 0. This bar above the A indicates a NOT function. So let's put the NOT gate in. So I'm going to remove my B because I don't need it. Just going back to my 4069 here, I'm inputting to pin 1 and outputting to pin 2. So I'm going to move my output here and put it to pin 2. So now I'm only using switch A. I could have used B, but it doesn't matter. And therefore the input is low and I haven't pressed it, and the output is high. When I press A, the output goes low. So when A is high, the output is low. When A is low, the output is high. And this bears out on our truth table. Moving on. Now we're going to be looking at a 2-input NAND gate. We're going to go back to our original pin configuration where we're using the inputs on pins 1 and pin 2 and the output on pin 3. And what it's telling us is that we have a high output when neither are pressed, when A is pressed, when B is pressed, but when A and B are pressed, we get a 0. In other words, you will notice that it is not an AND gate. So once again, we have our symbol for an AND gate, but we have this little dot here, and this little dot is indicating that it is a not an AND gate. So it works in the opposite way. Remember, our AND gate was 0, 0, 0, 1. Now we have 1, 1, 1, 0. So let's have a little look at that. So now neither A or B are pressed and the output is high. When I press A, it remains high. When I press B, it remains high. And when I press A and B, it goes low. So it works in the opposite way of an AND gate, therefore it is not an AND gate. Moving on. Now we're going to be looking at a 2-input NOR gate, a 4001. Power is all the same. So this is not an OR gate. And in our OR gate, if you remember, we had 0, 1, 1, 1. So when A or B were pressed. But in this case, it's not that. It's the opposite. So in other words, when both of them are low, the output is high. Otherwise, all the other outputs will be low. It is not an OR gate. Not an OR gate. And this little plus sign here indicates the OR, remember. So, our 4001. You can hear it snap into the breadboard, which is always worth making sure that you do properly. So at the moment the output is high. I press A, the output goes low. I release A. I press B, the output goes low. I release B. I press both, the output goes low. So the only time the output is a high is when A and B are both low. On this occasion here. Next, we're going to be looking at a gate that you do not need to know for GCSE, but you would do for A-level. But it's always worth knowing because it makes life a lot simpler. I'm not sure why they don't really include it in the GCSE syllabus. And this is called an EXOR, which means it is an exclusive OR gate. This little symbol here, which is the OR sign with a circle around it, means it's exclusive. This little bar here, this double bar from the end, means it's exclusive. Fortunately for us, again, the pinouts are identical as they were before. And what should we be seeing here? We should be seeing that when A or B are pressed exclusively, which means on their own, the output will be high. Here A is exclusive because only A is pressed. Here B is exclusive because only B is pressed. But here they're not exclusive because A is the same as B and here A is the same as B. This is a 4070. So A and B are both the same. I'm going to press A. The output goes high. I'm going to press B. The output goes high. I'm going to press A and B. See that quite flash? That's just the difference between me pressing A and B. A and B both pressed and the output is low. So only when A or B are pressed exclusively is the output high. And then finally, in our introduction to logic gates, we're going to be looking at the exclusive NOR gate. So again, this is the exclusive OR gate, but knotted. In other words, it should be the opposite of the exclusive OR gate. So we had 0, 1, 1, 0 with the exclusive OR. Now we have 1, 0, 0, 1 with the exclusive NOR. So when A or B were exclusive, they were high, and now they're not exclusive, and therefore they're high when they're not exclusive. This is our symbol, our exclusive OR with the bar across the top. And again, on our symbol, we've got the exclusive OR gate with the little circle. Let's have a look at the 4077. So, both of them are unpressed and the output is currently high. I press A, it goes low. I press B, it goes low. And I press both of them, it is high. The output is high. Okay. So that is our exclusive NOR gate. These are all the gates that you need to know when designing digital electronics. And what we're going to do, we're going to look at how we can combine different gates to produce different outputs. This is the end of activity 1 and activity 2.